All right, day 3 of chapter 5. We're going to fast forward a little bit and go to 5.8, which is all about modeling quadratic equations. Now, let's review the 3 equations that we have for quadratics right now. The first one, of course, is standard form. Standard form is our regular y equals ax squared plus bx plus c. Remember, there's not much that we can pull from that type of equation. The second form that we have is graphing or vertex form. Graphing or vertex form, which is y equals a times the quantity of x minus h, quantity squared, plus k. And remember, h is the opposite of what you think. And then our final form that we've been working with is intercept form. And this is different than, this is the x-intercept form. Y equals a times the quantity of x minus p times x minus q. So those are the 3 forms that we should be good at. Now what we're going to do today is we're going to model. Let's do our first example. Let's suppose that the vertex of a particular parabola is at the points -1, -2. And this goes through the point. This parabola goes through the point 5, 10. All right, what I like to do is I like to just get a sense of what's happening here. I make a quick little sketch. -1, -2 is our vertex, and we got the point 5, 10. This is the vertex, and it's going to go through this point. So what kind of parabola are we going to have? Well, one thing I know is that it's going to go and open up. That's the only way that this vertex is going to get through this point. So this parabola is going to go and open up. I'm not exactly sure if it's going to be wide, narrow, or normal, but I know our A is probably going to be positive. But let's take what we've got and plug it into graphing or vertex form. Since we have the vertex, let's put it in vertex form. Y equals a times the quantity of x. Now, h is -1, but it's x minus h, so it's going to be x plus 1, quantity squared, plus k minus 2. So, the one thing I don't know is I don't know what a is. So what we're going to have to do in order to determine what a is, we're going to plug in x and y, this point, into x and y. All right, so if we can have numbers for x and y, we'll have everything except a, and we can solve for a. That's where this point comes in. 10 equals a times the quantity of 5 plus 1, quantity squared, minus 2. Insert the point in for x and y. Then let's simplify here. So we got 10 equals a times 5 plus 1 is 6, squared is 36, minus 2. Now, does that mean that I can do 36 minus 2? Of course not. Check this out. This is multiplying. The order of operations suggests that we have to do this. We're solving for a, so we got to get rid of the 2 first. Add 2, you get 12 equals, this is a times 36, or 36a. Divide by 36 on both sides, you get 1/3 is a. 1/3 is a. So now that we know what a is, now we can go back to vertex form and write a more complete version of it. So this is y equals a, we now know is 1/3, times the quantity of x plus 1, quantity squared, minus 2. That is our equation. A is positive, just like we kind of thought it might be, and it's got our vertex here. Awesome. So that's if I give you a vertex and a point. The next example is going to be what happens if I tell you that the x-intercepts are -1 and 5. The x-intercepts are at -1 and 5, and the parabola goes through the points 6, -42. All right, so let's talk about this. They gave us the x-intercepts. Let's get an idea of what we're working with here. Our x-intercepts are at -1, -1, 5, And then we got a third point, 6, negative 42, way down here. Now, what kind of parabola is going to have these intercepts but also make it through this point here? I don't think the vertex is going to be here. The vertex is going to have to be somewhere up here so that it makes it through all three of these points. All right, so when we do this, I'm expecting to find our A to be negative. Now, which form are we going to use? They gave us the x-intercept, so we're going to use intercept form. So, y equals A, we don't know what A is, x minus p. Now, the first x-intercept is negative 1, so it's going to be x plus 1. Remember, because it's x minus p, it's x minus negative 1, so it's x plus 1. And then x minus q, which in this case is 5. All right, so again, we're trying to find A. That's where the second point comes in to play. Plug in x and y into our form here, and you get negative 42 equals 6 times the quantity of, or excuse me, oh my goodness, A. We don't know what A is. We know what x is. X is 6. 6 plus 1 times 6 minus 5. So we have negative 42 equals 6 plus 1 is 7. 8 times 7 times 1. So negative 42 is 7a. So A, of course, is negative 6. A is negative 6. So our final form here is going to be y equals A, negative 6, times the quantity of x plus 1 times x minus 5. There's our quadratic model. Smith out!